finished project. Most people, or many people, when they think of lapidary, think strictly of jewelry. That's a major emphasis on lapidary work, but it is certainly not the only emphasis, as we will see later on in the presentation. Lapidary work obviously starts with a rough material, a rock, a mineral. It doesn't matter. It doesn't even have to be a rock. It can be slag, the outer coat of a bowling ball, Fordite, which is nothing more than the paint from a Ford spray booth, or any of the other major companies' equivalent. And here we see two rough materials. The one on the right is obviously half a geode, or thunder egg, and the one on the right, on the left, can anybody venture a guess? Not U.S.
Quartzite? Quartzite?
No. Ocean jasper, Madagascar. Now we have a rock. What are you going to do with that sucker? Well, as Larry just mentioned, slab saw. Here's the one I happen to use. This one is an 18-inch. It started out life as a kit. The company that made it was in existence from the late 70s to the mid-90s, and I'm guessing that this was probably made somewhere around 1990. I got it used in 2002, maybe 2003, and it's got a lot of hours on it since. This is the outer side. The outer box on this one is wood. Many commercial ones are metal. It uses as a coolant, you got a choice: water, in which case everything inside will rust, or oil. I use oil. The old oil used in lapidary thing was called pellet oil, which you can still get if you want to pay for it. 15 years ago, it was 20 bucks a gallon. Today, I have no idea what it is. I haven't used it in a very long time. I use food grade mineral oil. You can get this from a variety of places. Tractor Supply has it. 10 years ago it was $15 a gallon. Currently it's about 30. And the saw takes 5.5 gallons. So an oil change is a big job. But not only from the pocketbook standpoint, but from cleaning the inside of the saw to get rid of all the gunk. Typically, you'll recover 5 gallons, give or take, of stuff. If you let it settle, you can, depending on how long it's been since you've cleaned it last, you may get 30% back. So you can recycle a third of it. The remaining part goes in the trash. And the remaining part is like a thick mud. Oil saturated, yes, but a thick mud. No liquid. An 18-inch saw, such as mine, you can cut just short of 8 inches in height. Larry's 10-inch saw, you can probably, I'm going to make a guess, you're going to get about 4.5 inches max cut. If you're cutting down specimens that you found in the field and you want to get rid of the garbage, okay, I can deal with 7. He can deal with 5, or 8 and 5. Your cutting depth is roughly 40%, 45% of the diameter of the blade. Here we see some slabs of various incendiary minerals, ranging from mahogany obsidian ocean jasper, probably onyx, red lace jasper, so-called wonderstone, some sort of an agate, petrified palmwood, serpentine, I think, from Easton. Once you have a slab, well, you've got to put a design on it. Okay, here's some traditional templates and a couple of scribes that you can use to scribe your design on your slab. This gives you a so-called calibrated stone, which is where most people start their lapidary activities. It's good to know how to do a calibrated stone, but one soon finds out that it is very demanding. In that, if you're going to use a calibrated stone, that means you're going to use probably a calibrated mount. A calibrated mount can be somewhat flexible, such as this guy. You can squish it, not quite so tall, which makes it a little fatter, or you can make it a little skinnier and be a little taller. And you may be able to do that maybe a millimeter and a half. For those that are not as familiar with the metric system as you might, there are 25.4 millimeters in 1 inch. Or a millimeter is just slightly smaller than 40 thousandths of 1 inch. Actually, it's closer to 38 thousandths. Here we see a circle. Circles can be very demanding. If you have a perfect circle, is it the right size? Is it too big? Is it too small? If it's too big, it won't go in. If it's too small, between the edge of the metal and the edge of the stone, you have a gap, which you do not want. Here's one with a solid back on it, and you don't have much slack in that one. And then here we have a bunch of ones where the amount of punch factor you have in size is probably on the order of 1/4 of a millimeter, or around 10 thousandths of an inch. If you go to a solid back circle, then that's where the metal meets the road. In that, if it's too big, it won't go in. If it's too small, it will go in, but you'll have that ugly gap. If it just fits the way it's supposed to, okay, you put it in and, oh, it fits. Now how do you get it out to add adhesive on the back of it to hold it in place? Because there is no prongs or bezel on the side to squish in. That's a big problem. When I first started out, I had a customer that wanted 6 identical bracelets like that. Figuring a stone, unless it's one color, no texture, you're not going to get, the front side and the back side won't be the same, let alone 2 pieces side by side. So you can't make identical things. I'll pass this around so you can take a closer look. Thanks, Pat. The silver colored ones are not stainless, they're sterling, and the yellow ones are gold filled. Gold filled is a base metal with a little bit of gold in it, but not enough to make it worthwhile to try to recover the gold. As I alluded to, if you're getting into lapidary, you're going to want to know something about the metric system. This book is a wonderful encyclopedia of everything you wanted to know about anything regarding minerals. It will give you whether they are fluorescent, how hard they are, where they're found, what their chemistry is, all kinds of information about them, as well as how many milligrams are in a pound, how many inches, or excuse me, microns are in an inch. Anything you want to know. And it also gives you ideas as to how to clean your minerals and how not to clean them, and polish them, and generally play with them. This is written by a fellow by the name of Johnson Kakis. This one, it was written in the early 70s, but it's a good working reference for a variety of stuff. Once we've got our template out, we describe our slab with it. In this case, we're trying to save a bug or a hole in it. In addition to the saw, we need some ancillary equipment. An apron helps if you're working with oil or water. Get rid of the splashes so you don't come upstairs drenched. A magnifying glass, a mask to keep the dust particles away from your face. While you're working with the materials, some thin latex gloves, or these are nitrile. And then when you're working with your big saw, if you're cleaning it, you're going to want longer, heavier duty gloves. Once you get your outer thing cut with a baby saw, here's a baby saw. This is a trim saw as opposed to a slab saw. This blade is 6 inches in diameter. Typically they're up to about 10. With a 6-inch blade, you could probably slice a golf ball, but that's about all. With a 10-inch, you could probably do a tennis ball. Here we see a basic, slightly basic, actually I should say slightly modified basic Lortone combination trim saw, grinding, sanding, polishing unit. Saw on the left. This is a part of this comes with the saw. It helps reduce but not eliminate oil spatter. When you first buy the saw, you have silicon carbide grinding wheels. Here's some carbide wheels here. Right now it's running a diamond wheel. It comes with an expanded rubber disc that you put sanding discs on, or sanding, not discs, belts. And they come in various grit sizes. Your grinding saw thing is typically 100 to 200, actually 80 to 200. So your sanding belts start at 200, and with carbide, you're limited to a max of mostly 600, which isn't very much, as we'll see very soon. With diamonds, you can go up to 100,000 if you choose. And on the end, we see a polishing disc. This one happens to have some green chrome oxide on it. Chrome oxide is good to polish green materials, simply such as jade, which is green. Cerium oxide, which is another commonly used polish, is tan, but most jade doesn't do terribly well with cerium, but it'll do very nicely with chrome. Here we see a cab that has been roughed out with trim saw, and one that has been then subsequently ground down to a shape, an outer shape, ready to put a dome on. Putting the dome on in the beginning, when you're first learning, involves using something called a dop stick. A dop stick is literally anything you can hold in your hand that has a flat head on it that you can stick a small piece of wax on. You then adhere your form, such as this, to your stick by warming the wax a little bit and jamming the stone into the wax. This gives you a handle to play with. When you're first learning manipulating the stone such as this, in real life this thing is about 1 inch from top to bottom, maybe 3/8 left to right. Here's a typical dop wax melter. It's a 1 burner camp stove, works with alcohol. And once you get around to cutting your cap, if this is the bottom, you're going to have a flat bottom, which you need to get rid of the saw marks on, which means you need to sand it by hand. Actually, you could put it in a dop stick, but then you got to take it off and reverse the dop stick. Ultimately, you're going to have about a 1 millimeter area of vertical side, and then you progressively make cuts of reduced angles until you have a dome. This one would result in a relatively tall dome. Sometimes you get a very flat dome. Larger stones tend to have flatter domes than smaller ones. Here we see a close-up of the Lortone unit with the diamond, not the carbide grinding disc, the sanding disc. This one's looks like it's a pretty well used 600 and polishing disc. Your grinding and your sanding discs or wheels come in grit sizes. Typically they go from 80 to 100,000. Grit sizes are sort of arbitrary. Here on the left we see grit size, and on the right we see the corresponding micron size. A 220 grit has a micron size of about 60 microns for 1 hunk of grit. On the other hand, if you go to 600, it's only half as big, even though the grit number is far more than double the other one. If you go to 1200, you're down to 9 microns in size. So size in microns is not linear, and grit size is not linear. They're sort of arbitrary. Most of the work I do currently, I stop at 14,000, which is a 1 micron size grit. On difficult cases, I'll go to 100 if I have to. I don't think I've used 100 more than a dozen times in 20 years. You don't use it very often. Let's go. Okay, let's start making a cap. Well, we start with this thin slab, sand the top and the bottom to get rid of the saw marks. Oh, yeah, okay. Now we come to rock hardness. Most of you are familiar with the mower's hardness scale, which is a numeric from 1 to 10. It's a relative scale. The difference between 1 and 2 is not 50%. The difference between 2 and 4 is not 50%. in absolute terms, talc has a hardness of 1. Gypsum, a 2. However, when you get to calcite, which has a Mohs of around 3, the absolute hardness is 14. And then you go up to a diamond, which is a Mohs of 10, you're up in the 1500s. That's according to one reference. There are other references that the differences are even larger. Dr. Moore was not the only one to develop a hardness scale. There have been at least 5 or 6 others. Not all cover all minerals, some only cover 2 or 3. But the first scale was in the early 1800s, if I remember rightly. If you're looking at the book somewhere, wherever it is, I think it's page 177 or 178, has a list of the various historic hardness charts. Okay, we got rid of that guy. Okay, let's start with making a cap. This raw material is a jasper. It's from this general area, from somewhere around Emmaus. I don't know where I got it from somebody at a show. Here's the starting slab. Okay. First we cut a rough dome on it. In this case, you notice that there are very definite ridges on the corners, which you will eventually get rid of. This is with a 70 grit cutting wheel. Well, let's refine the cut a little bit and go to 220. Well, we get rid of some of the ridges, but not all. And we go to 600, and again, we've gotten rid of most of the severe ridges, and it's actually starting to shine a little bit. Then we go to 1200, and the shine is starting to definitely make itself known. Then we'll go up to an 8000, pretty good shine. If you go to 50, there's a little bit of difference, but it's very hard to tell the difference between a 1 micron and a 0.5 micron finish. Once you get it shined up on the top, what are you going to do about the bottom? If you don't do anything with it and you just, you've gotten rid of the saw marks, okay, that's fine. If you can be absolutely certain that when it's put into jewelry, the back is going to be covered so you don't see it. If you try to wire wrap it, and you can see, or have an open back so you can see the back, it's going to look horrible. So you have to shine the back. Maybe not quite as good as the front, but at least darn close. Nope, wrong box. This is the box. In this box, we'll see a series of stones that have varying degrees of polish. Not all stones polish equally. This stone here just happens to be this guy. So you can see what a 50,000 on a local jasper will look like. On the other hand, here is a actinolite, probably felspar sample from Tom's Easton C.K. Williams quarry, and it's at best a satin finish. Here's a petrified wood, the back of which has been somewhat polished and is okay but not great. The front is strictly bark. Here's another piece of serpentine from Easton, some rhodonite from New Jersey, Not sure what that is. This guy I had no clue for. If anybody wants to make a guess, I'd welcome a guess. Also, while you're looking at it, I'll send this around as well, minus those. On this tray, you'll see a piece of Williamsite serpentine from Penn Mellor on the quarry in various stages of finish. The labels will show you where they are in the operation. This one is 80 grit, and then we go to 220, 280. These two are the wheel is hard. This one, the wheel backing is soft, meaning plastic, not metal. Here's a 600, and then we go 12, 3,000, 14,000. Just close it down. In addition to using a lapidary machine, many people just starting out will use one of these guys, a vibrating tumbler. Inexpensive, works for the most part, and it works by vibrating. You put your sample and grit in the chamber, let it sit there vibrating for about a week, and then afterwards take it out, clean it up, both the chamber and the specimen, add a finer grit, and keep it going for about a month with progressively finer grits. Somewhat noisy. And here we see a rotating as opposed to a vibrating tumbler. This, you have a bucket that moves on rollers and is a little slower. It takes a little longer with this one than the vibrating fella, but you can do larger loads and larger rocks. Here we see a flat rotating lap. Think of a Victrola in that it's roughly 1 foot left to right. This is a means of polishing a large flat surface. Problem with the flat lap like this, you have to hold the material on the surface, the rotating surface, and your pressure on the material must be even throughout, or you end up with parts of your specimen being polished and parts of it not being polished. You have hot spots. A rotating or vibrating lap is a much better choice. I accumulated this at a good price, so I won't complain, but I don't use it that much. Here are some of the discs that you can use for it. This one's a 70 grit magnetic back diamond abrasive. This one's a 400 grit, and here we see a 60 grit carbide with a adhesive backing rather than the magnetic backing, and a 600 carbide backing. The diamond discs are $200 to $300 a piece. These are currently probably about $5 a piece. Here we see a rough sample that's been tumbled, a rough sample that has been outlined, that is, we have an outlined shape, and then we threw it in the tumbler to polish it. And then here we see the traditional cabochon with a dome on it that has been finished by hand. These two are tumble finished, these are handheld to finish. Here's a bunch of raw material, raw cabs that were done in the winter of '21. a wide variety of materials. Mookaite, it's hard to tell on that one because it's half off the screen. These three are virginite, which is a high chrome fuchsite. These three are Art Deco glass culettes. That one is tiger iron. I think these two are fluorites. These are again from Easton, actually three from Easton. This is aragonite from Muhlenberg, onyx, aragonite from I don't know where, petrified palm wood, and I think petrified wood, but I don't know from where. Here we see a bunch of cabochons on the left. There are those that have not been set in jewelry, and those that are on the right have been set in a variety of forms, including wire wrapping as well as bezeling. All the bezels are outline bezels, and the back is open. And let's go down here. Okay, other polishing tasks that we can do. Well, we can do them for specimens, such as the material you saw before the presentation that was up there. That was, the green was a Williamsite from Penn, Maryland, and both polished and not polished. You can do picture slabs of pictures. You can facet. If you are a collector and you collected a lovely specimen that's tiny and it's in a huge hunk of rock that detracts from it, you can get rid of all of the detracting garbage and end up with a good specimen. You can also cut geodes with it. Here we see a red lace cabochon with a bug which contains quartz crystals. The setting is sterling. Here we see a half a Brazilian geode. I didn't cut that one or polish it, somebody else did. Here we see what I believe to be Mangano talc, but it may be Mangano, Easton, tremolite. I think it's talc, but it might be tremolite. Tom and I found 3 of these on one trip. And as far as I know, you haven't found any more since. Here we see some colorful Arizona petrified wood. So you can see the bark and you can see how lovely the colors are that develop inside of it. Here we see some chromite from the Woods Chrome Mine in Serpentine. Snowflake obsidian. Chrysocolla. Need a spell check on this guy. Malachite, azurite, and there's a black material in there that starts with an H, and I can never remember what the devil the name is. This is a quartz material found in Richmond, Pennsylvania. It's milky on the center, and the outer is smoky. That was picked up in a farmer's field, probably 10 years ago. And the next one, I think, is a red tiger eye, but it might be tiger eye, it might be tiger iron, uncertain, not certain. And here we see a picture jasper. If you don't like this picture, you turn it upside down, you turn it over and look at the back side so you can get four pictures in one. Here we see a relatively recent toy. It's a genie. It's the genie, not the Daisy Pixie or the king size Titan. This is a 6-inch diameter wheel. The Titan has an 8-inch, and the Pixie has a 4-inch. The big advantage of the Titan is that the distance between the wheels, instead of being 1 inch, which is about what this is, it's about 1 3/4 inches. This means you can make bigger materials. Try to make a big material here, and while you're working with one grit, you're overlapping on the one next to it. That's fine if you're working on a coarse grit, but if you're working with a fine grit and you hit the coarse grit to the one side of it, you're not going to be happy. And here we see on the other side of the genie, the 600, 1200, 3K. Notice that the genie uses a bubbling system, geyser system to get water to your sample, whereas the Lortone unit uses a drip system where you're always using fresh water and you won't get contamination of particles, particularly when you get in the final stages. When the machine, this is the Lortone. When I first bought the machine, you added liquid to the wheel with a hypodermic needle or a cannula, which is nothing more than a needle with no point, through a little hole, and you couldn't turn it, you couldn't adjust it, you couldn't turn it on or off, and it was forever clogging. I added a fixture to allow me to adjust it, and it's much happier this way. Here we see some more materials, half a geode or thunder egg. This guy is an amethyst geode, northern Mexico. Actually, all of these are northern Mexico. Oh, why is that big? Okay. Each one is different. You can never tell what it's going to look like on the inside. You think you know, and you guessed wrong. Here's a Palermo Mexican geode. Then we have further fun. On the left, we see the effect of light source on your rock. On the left, you see white light. On the right, we see shortwave ultraviolet. This sample is a piece of Art Deco glass. And here is some cabochons made with the same material. Again, the left is white light, and the right, spell check, come on. Is totally different. You would not recognize these from these. Although this guy is this one, and this one, and this one, and so on. Various minerals or metals added to the glass will change its color. On the left, we see a variety of chemicals and metals, and on the right, we see what the addition of microparticles, actually nanoparticles, of those materials they give the glass. In addition to glass and slag, we have, here's a piece of slag. I'll pass around in a second. It's basically black and white. This side's been shined and the rest has not. This is under white light. Probably, well, at distance you won't be able to see, but under UV, this is shortwave. It's sort of an orange. Here is something that many of you are familiar with. It's the Chevrolet equivalent of Fordite. Red. Well, put here, and it's sort of a nondescript mustard. I'll send both materials around. When you're using the light, please do not look into the light in the lens. You put up with me long enough, so enough. This is probably about 4 years old. That's it. Any questions?
Yeah, if you use wax to hold your
Yeah.
stone that you're making into a cabochon on the dopping stick, how do you get it off?
That can be a challenge. The easiest way I found is literally to put the dop stick and the stone in the freezer for about a half hour, and the coefficient of expansion and contraction will, for the most part, not always, but for the most part, let it fall right off.
Yeah, thank you.
The other way you can possibly do it is to loosen the stone slightly by warming and peel it off, and then you still have a thin layer of wax to deal with, but most of the wax you can get rid of with either 91% alcohol, rubbing alcohol, or acetone. For most of the stones, alcohol and acetone do not affect them, whereas acid would obviously be a no-no, and water would be a no-no for some.
And what kind of wax is it?
It's a special dop wax that has shellac in it, and you can recycle it to a point, and after a point you lose enough shellac so that it no longer holds, and your rock comes flying off. By the way, you cannot put much pressure on a dop stick when you're sanding with it. If you do, the stone falls off. I would say after the first 100 cabs, you will probably not use a dop stick anymore. Also, if you're going to polish both sides, top, bottom, a dop stick really has a problem when you try to put it on the top of a dome. It don't want to stay. Right now I will use a dop stick if the material I'm working with is smaller than my little fingernail, simply because it's too small to manipulate by hand. But if it's big enough to manipulate by hand, I have to do it by freehand. Now, yeah, you get your fingernails trimmed every once in a while, but it saves going to a manicure shop. Any other questions? Thank you.
Thank you.
All right, ladies and gentlemen, please feel free to linger and socialize. We do have one more item of business, and our secretary, Jen, has our road prize winner for this week.